Now let's try and gain a basic understanding of the polar representation of curves. Here we have represented two famous curves. One is the cardioid and another is Archimedean spiral. Now what is the advantage instead of representing this in using Cartesian coordinates when compared to they being represented in polar coordinates? One is of course the elegance and simplicity. Of course, as the discussion progresses, we will tell you how to convert from polar to Cartesian and Cartesian to polar. But to give you an idea how it is represented, in order to represent any curve in the polar form, we require two important coordinates. One is r, another is theta. Now r can vary from 0 to infinity and theta varies from 0 to pi. So that means r varies from 0 to infinity and theta varies from 0 to 2 pi. This is to be borne in mind. And all the curves that are going to be represented in terms of polar coordinates will have a relationship between r and theta. A relationship between r and theta would give you any polar curve. Because if you recall what we used to do in terms of Cartesian, for example, if you are looking at a circle with the center at the origin, this is nothing but for a given circle of a constant radius, it is a relationship between x and y, and here it is a relationship between r and theta. And if you want to represent a cardioid, which you would understand a little later how to do, it is nothing but 1 plus cos theta and r is equal to. So similarly, you can also represent an Archimedean spiral, and that is represented simply as r theta, right? In fact, we would walk you through the construction of cardioid via a basic animation next. But how exactly you are going to interpret this? Now, in order to interpret this, let's look at this curve a little more rigorously. Let's say that we are incepting from a point where theta is 0, right? So if theta is 0, and that is going to constitute this particular point. The reason being, the theta is reckoned from the positive x-axis as usual, and when I say theta is 0, the entire term reduces to 2. So obviously, if I call this O and if I call this O dash, it's very easy to observe that O dash is nothing but 2. This is very important. And you can also see here, we in fact travel all the way, you can see, travel all the way and hit this particular point at the origin. What is the value of r over here? It's a matter of basic inspection that r is going to be 0 at that particular point. How exactly are you going to achieve? Again, come back to this. When cos theta assumes value -1, theta is 180 degrees. That means you are you can imagine this particular vector. It goes on rotating. At this particular point, it completes 90 degrees because you can clearly see here. It's 90 degrees, and further it rotates and comes to this particular point. That is, it has rotated by another 90, but cos 180 is -1, 1 minus 1 is 0, so it comes back to this point. And this is repeated till it comes back to O dash. So the curve is beautifully traced. Since it is the shape of a heart, the word cardioid is perhaps applied. So therefore, this is how a polar coordinate must be understood. So as the radius sweeps through various angles, assumes various magnitudes, it is able to trace this particular curve. And also, you can interpret the Archimedean spiral, because at any point, whatever is the angle, the radius is proportional to that. So that is where you get actually the circles. So these are the two curves. Of course, we are going to deal with many curves in the forthcoming discussions. So one of the advantages of the polar representation is the elegance and simplicity. In fact, you would appreciate that if I were to represent the same two curves in Cartesian coordinate system, the expressions are going to look seriously complex. But here, the expressions look cool, they are very elegant, compact, and also the representation becomes very easy. And of course, even in integral calculus, you would appreciate that if you switch from Cartesian to polar, the integration also becomes very easy. Of course, there are several advantages of polar coordinates, but for now, what is very easy to appreciate is the representation and also the elegance of mathematical formulation. So both could be easily seen and appreciated. So now the next thing is we are going to convert these equations into Cartesian equations and see how complex they look like. And also, mind you, the polar curves could be plotted on typical graphing calculators available all over the web. And also, if you want to plot multiple polar curves, there are certain limitations. Of course, you can also copy the Python code that is available and then repeat that to plot multiple polar curves. You can also use MATLAB. You can also use GeoGebra. There are several applications which you can use. But for now, this is how the representation happens. As I explained, you begin with the positive x-axis, and there theta is 0 because theta is reckoned from positive x-axis. When theta is 0, what happens? The value of r becomes maximum. Given this expression, the maximum value of r could be 2 because maximum value of cos theta is 1. So therefore, the farthest point is hit here. And when theta is 180 degrees, it is 1 minus 1, that is r becomes 0. You come back to O because your radius vector starts from here, goes on decreasing as it is rotating. At 180 degree, what happens? It becomes the r value becomes completely 0, and then it starts increasing the negative sense, and then it becomes positive. Finally, it becomes O dash, because at cos 360 is also 1, mind you, so it comes back to 2. So that is what is to be remembered very carefully. So that was a basic understanding of the polar representation of a curve. Let's move on and understand how to convert from Cartesian to polar or polar to Cartesian. So let's get started.